Hi, welcome back to the Shiko SAT review series. And today we're going to finish the unit about the circles. Okay, so for the first video, we talk about the equation of the circle. How do we determine the circle equation for the given center point and the given radius? So we practice several problems. Some of them required to use the skill we learned in Algebra 2, complete the square methods here. And then the second part is here, we're going to talk the proportion among the arc length, circumference, sector area, and the whole circle areas here. So if you kind of refresh off memory, this is what we did on the first video. It's about it's all about the circle equations here. So the video will stop here. So here is our second video. That's what we're going to finish today. We're going to take a look at the proportion of the arc length to the circumference, the sector area to the whole area. So we have 7 problems to do here. Okay, so let me go to the whiteboard and we can start to work on this. Okay, so before we start, as always, we're going to have a little lectures here about the circles. So what we did for the previous video, we talk about the circle equations, right? So we said a circle equation is like x minus h squared plus y minus k squared is equal to the r squared. This is our circle equation. And the h of the k, this is the center, right? So this is the center of these circles, and the r is the radius of these circles here. And today we're going to talk about the relation for the circles and other things. So the first things here we have, we're going to talk a little bit about the measurements. For the circle, and we have 2 things. The angles we can measure by 2 different types of the units. We can say it's degrees, or we can say it's radians. Okay, so like in here for given circles, right? So for the given circle, the total degrees of these circles here. So that means if you start from here, then you turn around the whole circle. So the total degrees of these circles here is what? It's 360 degrees. So that means if you use the degrees to measure this circle, then the same way you can use, we call it radians here. So like if these circles here, so the total radians here is what we call it 2 pi. That means if you start in here and then you go around the whole circle is equal to the 2 pi. So that's why, because the whole circle is 360 degrees, also is the same as 2 pi radian. So we know they have a good relations, right? So that means 360 degrees is kind of equal to like 2 pi radians, right? So that means we know each pi is equal to kind of 180 degrees. So it's a pi radians equal to 180 degrees. So we will use these relations here. Okay, so the next thing here, we're going to talk about the circumference and the sectors, the arc lengths here. So let's take a look here. Okay, so for these circles here, right? So for these circles here, if I know the radius here, if this is r, okay, and then also if I have a kind of angles here, okay, so if this angle I call is x angles here, so I know the circumference, right? Circumference, that means the whole circle. So this is, what is circumference here? Is 2 pi r's here, right? So if I say this is the A and the B, if I'm looking for the arc length, this is what we call this, the arc length. Okay, to face this what? To face this angles here, right? So, whatever the angles, the ratio will be equal to the arc length, the length of this arc to this whole circumference here. So whatever these angles here, you can write these angles here to face like 360 degrees or 2 pi, depends, right? So it will be what? It will be equal to the length of this arc over the what? Over the whole circumference, right? So over the whole circumference. Like I say, if they give you the x's here, if the x is equal to what? If x equal to radians, so then you can say this is equal to the x equal to 2 pi's, right? So that means that for this number, for here, this is the x is in the radians. And for here, this x is in the degrees. Okay? So that means radians you compare to the 2 pi, and the degrees you compare to the 360 degrees, then the length of the arc they're going to have the same proportions here. All right. So then the next things here we call it is the area of the area of here. So they have the same things here. So it depends on the x. So you can say this ratio, x equal to the 360 is equal to what? So this will be equal to the area of the sector, right? So that's the area of the sector. I kind of the mark in the yellows, right? So then here, will be the whole circles. So this will be whole circles area. All right. So the same way, if your x is measured by radius, and then you can use the what? You can use x over 2 pi, right? So be careful here. This is radius, right? So if x you could measure by radius, and this is the same things here. So this is measured by degrees. So that means whatever the angles you face, see here, we call this angle, we call it the central angle. Then the arc length will be proportional to the circumference. And this proportion also, the area of this sector is also going to be proportional to the area of the whole circles here. Okay, so that's the whole things we need to kind of remember. That means the ratios here, the angles to the 360, and the ratio of the arc length to the circumference, and the ratio of the area of the sector to the whole circle. They are all equals here. All right, so let's take a look here, right? Okay, so now let's go to take a look at our examples here. Okay, so this example, they tell you the circles below the centers O has a circumference is 36. What is the length of the ACs here? Right. So I want to find the length of this arc AC. So, and I know in here, this is 90 degrees, right? So this is 90 degrees. So remember we said angle to the whole things here. So you can say here, this is 90 degrees face this arc, right? So 90 degrees for the total 360 degrees. It will be equal to the length of the arc, right? So this is the length, I'll use color coding of the ACs here. So this length is here, right? So will be equal to what? This whole circumference. So whole circumference is what? 36 is here. So that means I know this is 1/4 is equal to what? The length, right? 36, so this is the length of AC. So what is the AC here? So the length of the AC is what? The length here is what? It's 9, right? So basically it's 36 divided by 4 here. So you use the ratio. Okay, so the next ones here, they talk about, so they said in a circle, have a center O, central angle AOB has a measure of 5 pi over 4 radians. Okay, and the area of the sector formed by the central angle AOB is what fraction of the area of the circles here? Okay, so this one's here, right? So let's see here. So this one basically tell you I have a circles here, right? And then I'm also have angles here. I have AOBs here. So the O is here, so this is AOB, correct? Okay, so they said the AOB is here, the angles here is 5 pi over 4. I want to find the area, that means this little arc, the sector, and what is a fraction of the whole area, right? So we said, okay, so that's why it's always these relations, right? So this one here is what? Okay, so it's 5 pi over 4. Because this angle was measured by the radians, so what do we put it on the bottom here? It's 2 pi, correct? Okay, so now we want to find this is the area of the sector to the whole area. Okay, so now I said 5 pi over 4, and this is 2 pi. So remember, how do we simplify this one? See here, 5 pi over 4. 2 pi really you can write as 2 pi over 1, right? Then you flip, right? So this is 2 pi. Okay, so now what happens here? Pi and pi cancel. So that's what you have here. What do you have here? 5 over 8, right? So that's why we say the ratios here is what? So the area formed by this angle to the whole area. So that means this one is 5 over 8. That's what we mean here. Okay, and now the next ones here, if you remember these rules, then almost everything is the same, right? Okay, so now let's try it one more time. See here. So let's say a point, okay, so here, let's see here. I have a circle. Okay, need to give a little bit more space next time. Okay, so I have a point A and B, right? Okay, so here, this is A and B. And the arc length, the arc of A and B. So that means I say, okay, if in here, this arc, the length of A and B, this is pi over 3. And the radius here, this radius here, this is 1 here. I want to see what fraction of the circumference is the length of the arc, okay? So now, let's see here, okay? So the circumference is here, right? So the first thing is here, because the, because the radius is 1, so what is the circumference? The circumference is 2 pi r, right? So it's 2 pi here. So they tell us the AB, the arc is pi over 3. So what is that? So we just be pi over 3 over 2 pi. So the same way we can simplify it. So it's pi over 3 switch, right? So this one's here, it will be the switch here. This is 2 pi. So now pi and the pi is canceled. So it's 1 over 6. So I know this arc here is 1 over 6 of the whole circumference, right? So here, this is what? This is my circumference, right? So this is the circumference. Okay, so now let's take a look at problem case here. So they say the point C is the center of the circle. What fraction of the area is the area of the shaded area? Okay, so this is the same way. So this is 100 degrees, right? The problem here is 100 degrees. So like we talk about during the review, so it's like this is 100. Because this is measured by the degrees. So what do we need to put here? We need to put a 360 degrees, right? So this will be equal to the area of a sector, right? This yellow area to the whole circle area, correct? Okay, so now we can see here, so the 10 and the 360, we can simplify the 10, 10, and this is, we can divide it by 2, so it's 5, and here 30 is 18. Okay, so our answers here is 5 over what is 18, right? That means, you know, if you have 100 degrees angle, then the area of this yellow sector, right? So area of this yellow sector compared to the whole circle is 5 of 18 of the whole circle, right? So that's the rule we talked before. Okay, so now the problem L here, the number of radius in the 720 degrees angles can be written as a pi. So a is a constant. What is the value of, what is the value of a here? Remember, during our review, so we said 180 degrees is equivalent to what? To pi here, right? So we can write, we said 720 equivalent to, the 180 pi is equal to how many? Equal to pi, right? So the x here will be what? So you use the cross product. So x will be equal to 180, and this is 720 times pi. So I think 720 divided by 180, so it's 4 pi's, right? So that's the answer is 4 pi's here. Or you can just say the 780. So if you times 4 this side, times 4 this side, so this gives you 720 equal to 4 pi's here. All right, so the next ones here is pretty easy. For the circle below, point A is the center. The length of the arc is 2/5. So of the circumference of the circles. So what is the value of x here? Okay, so here, let's take a look here. So let's say the length of the BCs here. This is the arc BCs, right? So let's say so remember we used our ratio definitions, right? So we say, because this is measured by what? This is measured by degrees. So we say x over 360, right? Is equal to this length of arc, right? So this is the length of BC over to the circumference, right? So equal to the circumference. And the problem tells us the whole thing's equal to what? So this is what? So this is 2/5, right? So it says the ratio is the BC is 2/5 of the circumference. So that's why I can get x equal to the 360 is equal to the 2/5, right? So then you use cross product, 5x is 720. So what is the x here? So the x is equal to 720 divided by 5. So that is 144 here. All right. So that's pretty, that is basically it's the same things here. Okay, and then the last problem here, we said the circle below the center, below has a center O. The length of the ADC is 5 pi, and the x is 100 degrees. What is the length of the ABCs here? Okay, so let's take a look. So we said this length is what? this length is 5 pi, right? Okay, so this length is 5 pi, and x is 100th, right? So what is the length of ABCs here? Okay, so that's, remember we said, okay, so x is 100 degrees, so we use 100. Because it's 100, I use degrees, so it's 360s, right? So these ones here will be same like the ratio of the length, right? So it's the same thing we use many, many times. So it's the length of the AC over what? Over the circumference. Okay, so the length of the AC is 5 pi. Here is the circumference. All right, so I know here the whole circumference. So if you do a cross product, all right, so you do a cross product, so the whole circumference will be equal to 5 pi times 360 and divided by what? Divided by 100. So the whole circumference is 18 pi, right? So that means the whole circumference is 18 pi, but the problems here, the problem asks us the ABC, right? So this is the ABC, right? So this is the arc length. The problem asks us, so the length of the ABC, what is the answers here? The answer of the ABC, because the whole circumference is 18 pi, right? So it's 18 pi. Then I need to minus the length of the arc of AC. So minus how many? 5 pi. So what is the answer? It's 13 pi, right? So that's the answers here. All right, so that is the whole, about the circle. So let's try to go back here. So remember, right? So this is very important, right? So like the ratio of the angle will be equal to the ratio of the arc length over the circumference, or it will be equal to the area of that sector over the whole circle's areas here. And be careful, depends on what the problems give you, right? So if a problem give you in radians, then you need to use the x over 2 pi. If the problem give you is degrees, then you use x equal to the 360. And I think that all, we should cover the majority of the SAT circle problems here. That's the most common type of the problems in the SATs. So try to practice it and see, you'll be able to reproduce the answer or not. And so it's nice to talk to you, and we finish the circle. Then we're ready to go to the next unit here. All right, so it's nice to talk to you, and have a good day. And I'm looking forward to talk to you in our next videos here, right? Have a good day, and don't forget to practice, right? The practice, practice, and practice. That's the way to make you getting better in the math. All right, bye. Talk to you later, all right?